Hello, this is Mr. Mac. Now in this video, we're going to be talking about different types of variation or variation functions. Now there are basically four types of variation functions that I want to talk about. The first type is what we call direct variation. Now direct variation gets its name because you have two things that vary. They vary directly. And what that means is if you have x and y and they vary directly, as x goes up, y goes up, and as x goes down, y goes down. Now the equation for direct variation, if x and y vary directly, is y is equal to kx. Now we could also say that x and y are directly proportional, and when we say that, we get this fact that, let's see, it doesn't really matter, but how does the book put it? They put the y's on top. Okay, so we can say also, if we want to, that y1 over x1 is equal to y2 over x2. And so this, another way of saying that x and y vary directly is to say that they are directly proportional. There we go. Because y1 over x1 equals y2 over x2 is actually a proportion. Now, let's look at an example. We could say that y varies directly with x. Y is 12 when x is 7. What is y when x is 28? Okay, now you would work that something like this. If y varies directly as x, we think y equals kx. Now we know that we have 12 for y when x is 7. So solving this equation, we get k is equal to 12 sevenths. Now we want to know what is y when x is 28? So we'll put y equals 12 sevenths times 28. And if we multiply, think of this as 28 over 1, the 7s will cancel out here when we get 48. So when x is 28, y is 48. And that's direct variation. Now, we could go back and use this alternate formula, y1 over x1 equals y2 over x2. And if we did that, y1 would be 12, x1 would be 7. So we have 12 over 7 equals y2 over x2. We want to know y, so y2 over x2 is 28. Now, if we cross multiply, we get 12 times 28 is equal to 7 times y2. And we could divide both sides of this by 7. And the 7's cancel here, and 7 goes with it. 7 here, leaving 4. And so we get y2 equals 48. So either of these formulas will result in the same answer. Varying directly and direct proportional are two different ways of saying exactly the same thing. And that's direct variation. Now, the next type of variation that we get, let's move this up here, make it small. The next type of variation we get is joint variation. What happens here is we have a quantity, say y, that varies directly with two different quantities. We can say y varies jointly with x and z. Now, the equation for this kind of variation is y equals k x z. And what they'll do, let's just take this and put it over here someplace. What they'll do is they'll say y is 12 when x is 2 and z is 8. What is y when x is 8 and y is 24? Okay, so we start out and we use the condition that we have, all three of them. Y is 12, x is 2, and z is 8. So we have 12 equals k times 2 times 8. Okay, so that gives us 12/16 equals k, because we divide both sides by 16. And this simplifies to 3/4. 3/4 equals k. Now we go back and we put in the conditions we have and the unknown to solve for the unknown. Y equals 3/4, that's k, x 8, z 24. Okay, now, the 4 will cancel with the 8, leaving a 2. We get 3 times 2, which is 6, and 6 times 24 is 120, 144. I seem to be hung up on that number. So when x is 8 and y is 24, when x is 8 and z is 24. Oh, shoot. Did that mess you up? I hope not. The question is, what is y when x is 8 and z is 24, not y? So we put in 8 for x, and we put 24 in for z, and we solve for y, because that's the equation. Y is equal to kxe. And so we get 144. And that is joint variation. Now, when, let's see, delete. Sometimes we, oh, and by the way, let's just group these and minimize those just in case we need them again. Put it up with the other stuff here. Now, the third type of variation that we get is inverse variation. It's here someplace. I didn't lose it, did I? Well, let's just put it in again here. 3, inverse variation. Okay, now, inverse variation is as one quantity goes up, the other goes down. That's why we call it inverse variation. And the equation for inverse variation is xy equals k. Or we could say x1, y1 equals x2, y2. Now, either of these will work. Now, let's try this. Y varies inversely with x. Y is 144 when x is 3. What is y when x is 18? Okay, now we're going to use this equation first, xy equals k. So the condition we have is xy equals k, and x is 3 when y is 144. So we get k is, ooh, what is that? There's a 2 and a 3 and a 4. 432 is equal to k. Okay, nice big number. Now, what is y when x is 18? So now we're going to say 18y equals 432. And all we have to do is divide both sides by 18, and that'll tell us what y is. Now, I don't really know what that is. Let's see if we can figure it out. 18 is going to 43 probably 2 times. 2 times 18 is 36. Subtract that, we've got 7, 72. 18 goes into 72. 5, 4 times. Okay, so we've got 24. So y is 24 when x is 18. Now, we could go back and solve this equation using the second method for inverse variation, x1, y1 equals x2, y2. Yeah, let's do that. Okay, so we're going to get rid of this work here, and we're going to do it again this time. We're going to say x1, y1, that's 3 times 144, is equal to x2, 18, y2, which is y. So now, if you'll notice that we're really solving the same equation we had before, we're just dividing both sides by 18, and so we get y on this side. Now over here, we can do something simple here. The 3 goes into the 18 6 times, and then yes, 6 goes into 144 24 times. So 24 equals y. We get the same answer either way. All right, and that takes care of inverse variation. Now, the fourth type of variation that they talk about is combined variation. Once we have direct variation and inverse variation, combined variation gives you something like this. Let's first of all, let's put up here combined variation. This is for combined variation. Now, this one's a little bit more complicated. What we're going to do is we're going to say, let's just come up with an example. Y varies directly with x and z, and inversely with r and q. Now, in that particular case, this is y varies directly with x and z, and inversely with r and q. The equation would be y equals k xz divided by rq. Now, what would happen in this particular case is you would be given a base case where you know y, you know x, you know z, you know r, you know q, and you put all of those in this equation and solve for k, and then they'll give you all of the individual values except one of them, and you put those in where they belong and solve for the unknown value, and that is joint and combined variation. Now, I will be doing some solution videos on selected problems. I really recommend that you take a look at them, but those are the concepts for the different types of variations that we want to study in Algebra 2. And we're done.